During the 1970s, Coco, a young gorilla, gained global attention for her ability to use human sign language. However, some skeptics argue that animals such as Coco, chimpanzees, and dolphins that have learned to speak may not truly comprehend what they are saying, as using human language to represent things that may not exist physically could be pointless. Karen Bacher, a professor at the University of British Columbia and a fellow at the Harvard Radcliffe Institute for Advanced Study, explains that there are two groups of researchers, one keen on examining if animals can engage in symbolic communication and the other arguing for understanding non-human communication on its own terms, without anthropomorphizing. Today, scientists are utilizing advanced sensors and artificial intelligence technology to decode and observe how various species, including plants, share information with their communication methods. Bacher's new book, The Sounds of Life: How Digital Technology is Bringing Us Closer to the Worlds of Animals and Plants, delves into the field of digital bioacoustics. Scientific American interviewed Bacher about how technology can aid human communication with creatures like bats and honeybees, and how these discussions are prompting us to reconsider our relationship with other species. Attempts to teach non-human primates human language in the mid-20th century were controversial due to an anthropocentric approach. The field of digital bioacoustics now focuses on understanding complex communication in animals on their own terms. Combining digital listening and deep listening traditions, we may be on the brink of discovering language in non-humans and achieving interspecies communication. Digital bioacoustics uses small, portable digital recorders to capture non-human sounds in remote places where scientists cannot easily go. Artificial intelligence is used to detect patterns in this large amount of data. AI can detect patterns in non-human communication using natural language processing algorithms, which are also used in tools like Google Translate. In the bat chapter, Yossi Yovel monitored nearly 24 Egyptian fruit bats and recorded their vocalizations, which were analyzed by a voice recognition program. This revealed that bats have a much more complex language than previously thought, with specific sounds correlated to social interactions and even individual names. Deep learning algorithms can derive patterns from this instrumentation that we could not access with the naked human ear. Similarly, Tim Landreth studies bee communication and has developed a robot that can communicate with bees using their specific signals. This raises philosophical and ethical questions about controlling the behavior of non-human species. Digital bioacoustics combined with artificial intelligence is like a planetary-scale hearing aid that enables us to listen anew with both our prosthetically enhanced ears and our imagination, opening up new ways to think about conservation and our relationship to the planet.